Hey everyone, lesson 4, here we go. We're going to be learning two things today. We're going to be learning about what are special about parallel chords, and we're also going to talk about what are cyclic quadrilaterals. So mini lesson is right now. Don't forget that you have an exit slip that's going to be due Friday by midnight, and your homework is due Monday by midnight. So make sure you're up to date with that. I'm going to do the fastest recap of your previous lesson, which was about inscribed angles. Inscribed angles an inscribed angle is one whose vertex lies on the circle and whose rays intersect the circle. So right over here, we got an angle. We see the vertex is on the center. Sorry, it's on the circumference of the circle. And then the endpoints of our angle are also on the circumference. We also learned about its special property, that the angle is half the measure of the intercepted arc. So let's say, for example, that this angle was, let's say, angle 30 degrees. The intercepted arc, which is arc ND, if the angle is half, then the arc is double. So our arc must be 60 degrees. Again, let's use our property. The inscribed angle is half the measure of the intercepted arc. Is that true? Yeah, 30 is half of 60. Boom. All right. So the first thing that we're going to talk about today is what's special about parallel chords. So if you were looking at this picture, I want you to ask yourself, if you had to make an assumption, what is true? So some of you might be able to say, oh, maybe it has something to do with, the lines themselves. Maybe it has to do with the arcs that they intercept. Well, what I want to ask you is, well, what if I do, can I click on it? Let's see. What if I get rid of this and I reveal this to you? What does that remind you of? Yeah, parallel lines cut by a transversal, all right? And I gave a little example here that if angle C, or rather we can say CDA, if that's 42 degrees, then this angle must be, 42 degrees as well, because we know that alternate interior angles are congruent. So if that's true, right, what could we say about arc BD? Well, we know that this angle right here, that I'm outlining, is an inscribed angle. Inscribed angles are half the measure of its intercepted arc. So if it's half of BD, then BD is double that. So double 42 is 84. But similarly, so let's do this color. If I outline this angle in black, right? What's the measure of its intercepted arc? Angle D is also an inscribed angle, right? So it must be double the angle. So arc AC, or rather the measure, I should be saying the measure of these things because we're talking about the number. The measure of these arcs, AC, would also be 84 degrees. So what does that tell you? Yeah, arc AC and arc BD must be congruent. So this is actually a theorem. So it's something that is proven. And actually, if you completed the practice problems from yesterday and you looked up the answers, because we posted a video of the answers like we do every single day, you'll see that that you did a proof. This theorem says that if two chords are parallel in a circle, of course chords are in a circle, then their intercepted arcs are congruent. Okay, so let's do a problem and see what this looks like. Oops. Okay, so let's get a different color. Perfect. So again, the theorem, if chords are parallel, then their intercepted arcs must be congruent. So in this question, it says, if the measure of arc AC, so that's this arc right here, I'm going to do a little scribbly. If this arc is 92 degrees, boom, what is the measure of this arc? BD. Now, if you also said that it's 92 degrees, you're technically wrong, because those two arcs are only congruent when the lines are parallel. Did I tell you that AB and CD were parallel? No. So if now I put this here, right, the notation for parallel, right? Now, what could you say the measure of BD is, of arc BD? 92. Okay, so if chords are parallel, the arcs that they intercept, boom, are congruent. All right, okay, so that was first thing we're learning today. The second thing that we're learning today is something about cyclic quadrilaterals. Okay, so before we even do anything, we're going to be doing a noticings and wonderings. Okay, so what I'm going to ask you to do is I'm going to ask you to pause the video and come up with some things that you see in this picture and some things that you wonder. I'll give you some time. Wow, you all came up with really cool things. Okay, so let's go over it. So I see that some of you wrote that there's a quadrilateral in the picture. So yeah, ABCD is a quadrilateral. Remember, quadrilaterals are four-sided figures. I see that some of you wrote that all the interior angles add up to 360. That makes sense because we know that some of the interior angles of a four-sided figure, sorry, a four-sided polygon is 360. Some of you noticed that D and B added to 180 degrees and A and C add to 180 degrees. That's interesting. Some of you said that you wonder, do that all the angles that are in this picture, so the angle D, A, B, and C, notice that they're all inscribed angles, right? Because the vertexes or the vertices of each angle are on the circumference of the circle. Does that mean, does that make it a cyclic quadrilateral, whatever that means? And then one of you said, well, you know, the opposite angles being a supplementary, meaning they add to 180. Does that also, is that a property of being a cyclic quadrilateral? Well, those are all great ideas. So let's talk about it. A cyclic quadrilateral, one of my favorite words in geometry, cyclic quadrilateral, is a quadrilateral that is inscribed in a circle. So remember, inscribed means that all of the vertices of the shape are on the circle. Remember, on the circle means on the circumference. So you're right with all those being inscribed angles because all the vertices were on the circle. Properties of cyclic quadrilaterals is that opposite angles are supplementary. And remember, supplementary means that two angles that sum or add, right? Sum means to add up to 180 degrees. So let's see what this looks like. Quadrilateral DEFG in a circle, and measure of angle D is 86 degrees. So let's fill that in. So measure of angle D is 86 degrees. Find arc GFE. So this is kind of like a throwback. GFE is, you know what? Let's do, actually, let me do something that I think might be a little bit easier. This is the arc that we're looking for. My hands are very shaky. And you can see that these 2 points are kind of like the endpoints of the arc. And it meets at this angle. What type of angle is this? An inscribed angle, Mr. D'Souza. Oh, yes, it's an inscribed angle. And the measure of the angle is half the measure of the intercepted arc. So the arc is double the angle. So I'm going to do 86 times 2, and I get 172 degrees. Awesome. So now what I'm going to do is I want to know the measure of angle F. Well, in this picture, it's a four-sided figure that's inscribed in a circle, so it must be a cyclic quadrilateral. Angle D and angle F are opposite each other, right? They're not next to each other, like D and E are next to each other, and D and G are next to each other. D and F are opposites of each other. And we know that opposite angles in cyclic quadrilaterals add up to 180 degrees. So what plus 86 is 180? So I can just do 180 minus 86. You get 94. So the measure of angle F must be 94 degrees. Okay. So these were kind of like two lessons kind of just quickly put together. So just to quickly go over the two things that you did today. Parallel chords. If two chords are parallel in a circle, then their intercepted arcs are congruent. So these two chords are parallel. Let's make it obvious. Then the arcs that they intersect, so these two, must be congruent. Okay. Then we learned about cyclic quadrilaterals. Cyclic quadrilaterals is a quadrilateral that's inscribed in a circle, meaning all the vertices touch the circumference of the circle. And then the properties of cyclic quadrilaterals is really just opposite angles are supplementary, meaning they add to 180. So in this example, angle D plus angle F is 180 degrees, and angle E and angle J also add up to 180 degrees. All right. I hope this was helpful. You're going to see a video being posted soon that are going to go over practice problems. There's only 4 practice problems today. Yeah, I hope this was helpful, and I hope you have a great rest of your day. I'll see you later, everyone.